And we're back and we're going to solve another exponential application problem. So here we're given a supply function and the demand function for a certain type of Blu-ray player. And they're given by S of P equals 500 e to the 0.0004 P. So there are 3 zeros in front of that 4. And D of P equals 408 e to the negative 0.003 P. So 2 zeros in front of that 3. Make sure we notice that. So S of P represents the number of Blu-ray players the company is willing to sell, how much they are willing to supply at price P. And D of P represents the quantity that the public is willing to buy at price P. So we want to find the equilibrium price such that the demand is equal to the supply, so that we're making the right amount of Blu-ray products that people will buy them. So if I was the manufacturer of this product, I might say to myself, well, if I make 100 Blu-ray players and I sell them for $1 million each, well, there we go. I've got $100 million. I'm golden. So I would only need to make 100 and I'd be rich. However, the caveat arises when you ask yourself, would the general public be willing to pay $1 million for a Blu-ray player? So in that situation, there would be no demand for my product. Nobody would want to buy it. So I would have made all of this product and not sold it. And at the same time, if I told you, hey, I've got a Blu-ray player that we can buy for $1, you'd go, all right, I'll take you up on that offer, right? But there's a certain point where maybe you wouldn't be willing to buy it. There's a certain value. And I know most of you were going, well, who even has a Blu-ray player anymore? Miss Stein does. She still does in 2020 and watches Blu-ray discs. But anyhow, let's find the price where me, the manufacturer, and you, the general public, are happy enough that we're willing to buy and sell them so I can make money and you have a product you're satisfied with. And that kind of talks to us a little bit about what the equilibrium price is. So you've also seen equilibrium price or a break-even point on one of your labs you turned in with me, right? And so that was where the cost was equal to the revenue. So we're doing the same thing here. We're going to set supply equal to demand, and we're going to solve for our P value. So looking here, I have a supply, I have a demand, and we want the demand to be equal to the supply, so I'm going to set them equal. I have 150 e to 0.0004 P. That needs to equal 480 e to the negative 0.003 P. Okay, so we need to isolate P, and we have two P's. They're both in the variables. So this can get a little tricky, and I like to show you this example just so you see this method of manipulation that we're going to use to help us solve this. So one thing I could do is divide by 480 on both sides. So that leaves me with 15 over 48 e to the 0.004 P equals e to the negative 0.003 P. And you may have noticed I left a 0 out over here on the left. We need 3 zeros in front of that 4 P. And 15 over 48 can reduce to 5/16. So I'll just do that to clean this up a little bit. So I have 5/16 e to this big power equals e to another big power. So I'm going to divide on both sides by e. This is what I'm going to do to collect those P values. And I did it again. Got to make sure we leave 3 zeros in front of the 4. And what this does is it cancels on the left, and I end up with 5/16 equals this ratio of E values. So when I'm dividing same bases, I can subtract their exponents. This would be negative 0.003p minus 0.0004p. And what that calculation gives me is negative 0.0034p. So the right side of this equation has simplified to e to the negative 0.0034p. At this point, to solve the equation, I can take the natural log of both sides. So I have the natural log of 5/16 equals the natural log of e to the negative 0.0034p. And what we know about the natural log of e is that that is going to cancel, because natural log is base e, and the argument is e, base e to some exponential power. So I have now the natural log of 5/16 equals negative 0.0034p. And at this point, to solve, I would just divide on both sides. So the natural log of a fraction, 5/16, if it's less than 1, we're always going to get an output of a negative number. So dividing by this negative 0.0034, that's going to give me a positive output, negative over negative, positive output for p. And so plugging that into my calculator, I end up with 342.103194. So roughly, and what does it say to round to here? It is not specified. We'll just round to the whole number because we're not going to make part of a Blu-ray disc player. So in this case, the ideal price would be $342, which this problem must have been written a long time ago, because I doubt any of you would pay $342 for a Blu-ray player in 2020.